All right, let's see. One second. You see it down there in the bottom? 2, 3, 4. All right, here we go. So a square root is literally a square's side. And the way you find an area of a square, all the sides are the same, is you take the side and you square it. So a square root, that's the symbol that means square root, right? A square root, if you have an area, it's asking how long is the side. And the thing about this is the way you find the area is you take the side squared. That's what area is side squared. And so, square roots ask a question. Like this square root right here is asking, what squared is A? That's what this square root's asking. Okay? What number times itself equals A? So it doesn't matter what A is. Whatever A is, it's just a number, right? So like if it was 9, then the answer would be 3. So like, this is the one that's causing you guys a lot of trouble. The square root of A squared. This says, if you read this, it says, what squared is A squared? And that's kind of like saying, what's my dog Charlie's name? Charlie. My dog Charlie's name is Charlie. What squared is A squared? A. Not A squared. A. A squared is A squared. Yeah, the answer would just be A. So because, and the reason that's true, is because if you take your answer and you square it, you get the radicand. Right?
Does it matter like what the exponent is?
Yes, it does. Absolutely. And we'll get to that in just a minute. Okay, so, woo, gravity. Just jumped off the cliff right there. So check this out. Let's do 36k cubed m to the 4th. Let's do this one. Watch. This is asking what number times itself. So what number squared equals 36k cubed m to the 4th? That's what this is asking. What number times itself equals that big ugly thing right there? That's what this is asking. Okay? Now, I'm going to tell you that this equals 6k m squared times the square root of k. I'm not going to tell you how I got it, but that's what it equals. I promise. I promise. And here's how I know it's true. Because I'm going to put that right here. I'm going to square it. 6k m squared times the square root of k squared. And when I'm done, it's going to equal the radicand. That's how I know this is true. This is asking, again, this thing right here. This whole thing. Right? This whole thing. It's asking a question. It's asking, what number times itself equals just the radicand? What number times itself equals the thing on the inside in here? That's what it's asking. I'm telling you that this is the answer. This is the number times itself that equals the radicand. So I'm going to find out. So I'm going to take this number and multiply it by itself. That would be 6k m squared square root of k times 6k m squared square root of k. Multiplying that number by itself, right? 6 times 6, 36. Ooh, we're looking good so far. Oh, k times, okay, I'm going to scratch those out. Make them look like your picture in the yearbook. K times k is k squared. Ooh, that's making me nervous because I got a k cubed. Oh no. Well, got them done. Okay, m squared times m squared. M to the 4th. What's the square root of k times the square root of k? That is just equal to, you're right, k. And isn't k squared times k cubed?
Yeah.
That's how I know this is right. If I were asked to show this is the answer for that question, what I would do is I take the thing I was given as the answer and I would square it and show that it equaled the radicand. Now if you're not sure, radicand for this thing is 25. It's the number inside the square root. That's called the radicand. Okay? Alright, now, because square roots are, well, looking for perfect squares, right? Like the square root of 9 is 3, and the square root of 100 is 10. Because square roots are looking for perfect squares, if you have something that's not a perfect square, like 18, what you do is you factor, and you look for the biggest perfect square. So if I have 18, right, that's 1 and 18, 2 and 9, and 3 and 6. Those are all the factors. That's the perfect square right there. So this is equal to the square root of 9 times the square root of 2. And the square root of 9 is, of course, 3. The square root of 2 is just the square root of 2. I'm done. Now I could check it. I could multiply this number by itself, and it will equal 18. But, yeah. All right. Now, ugly one. Oh, no. Let's do 300. Oh, my good Lord. We're looking for perfect squares here, right? Isn't x squared a perfect square? What times itself is x squared? X. So the square root of x squared is just x. I got that part down. So I'm pretty sure my answer is going to be x something. 300. Famously known as 100 times 3. Oh! What's the square root of 100? 10. There's your answer. The number times itself, this is asking the number times itself that equals 300x squared. The number times itself that equals 300x squared is 10x times the square root of 3. For sure. For sure. Okay, almost done. I got 3 minutes because I told you 10 minutes less. You ready?
Jump.
Okay. Uh-oh, this is going to make me nervous now. Let's do 2 times the square root of 48. How would we handle that? Oh, good golly, Miss Molly. This is making me very nervous. Well, the square root of 48. 48 is 16 times 3, and the square root of 16 is just 4, right? And do you see, Rachel, this is multiplying by 48? So the square root of 48, though, is 16 times 3, so it's that. So 2 times 4 times the square root of 3. So that's equal to 8 times the square root of 3. This whole thing right there equals that. All right? Now, what if I had something like this? Oh no. Oh no. This is making me very sad. I got 2 minutes left, so here we go. We just did this part. 8 root 3, right? Now, isn't 27, isn't that 9 times 3? And the square root of 9, isn't that 3? Oh, and the square root of 45, isn't that 9 times the square root of 5? So that's 3, and 3 times 5 is 15. Oh, the square root of 5. So these two are like terms, and this is different. So 8 and 3 is 11. And there you go. And you don't add the 3's. It's not square root of 6. That'd be like the whole thing we talked about with the dollar bills and stuff. 8 $10 bills is not 8 $80 bills. Last one, reducing. This is just equal to 2. Because 8 divided by 2 is 4, and the square root of 4 is 2. That would work the same as this. That's the same as this. Absolutely. So if you had something like the square root of 45 divided by the square root of, well, I don't know, 5, that'd give you the square root of 9, which is 3. Do you see? And last one, we had something like 2 square root 15 divided by, let's see, the square root of 40. Oh, I'm going to go over time. Dang! Should I just stop reviewing now? Should Should I finish? Okay. Dang, sorry. I tried. Okay. 2 root 15. Now 40, isn't that 4 times square root of 4 times the square root of 10? 40. And so this is 2 times the square root of 10, right? So 2 times the square root of 10. You see? 2 goes into 2 one time, and I'm left with the square root of 15 over the square root of 10. But wait, there's more. Call now. Just pay extra shipping and handling. 5 goes into both of those. This is the square root of 3 over the square root of 2. Or, if you wanted, neither of these is better. You could do either way. Now there's a thing we haven't learned yet called rationalizing the denominator, but we're not going to worry about that yet, so we're done. So there we go. In under 11 minutes, a minute extra. Covered everything you have to know about square roots.